Hey there, it's Kelly here today to talk to you about arrays. Now, arrays are probably the data structure that I've used the most in my classes. It's very important that you understand how they work and how to use them properly. You've probably declared an array before. You start off by listing the type of element that's going to be stored in the array, followed by the array name, brackets, and then the size of the array. Then if we want to access an element of the array, we just type the array name followed by brackets with the index of the element that we want to access. Remember that arrays are zero indexed, so if you want to access the first element, you're going to be accessing element 0. Now, if you want to create an array on the stack, the size of the array has to be known at compile time. This can be useful for arrays of small constant sizes, but what if we wanted an array where the size depended on, say, the user input? So there must be a better option. That's where arrays on the heap come in. Just like we can create integers and doubles and all types of variables on the heap, we can also create arrays on the heap. Let's take a look at an example of how we would declare an array on the heap. So here I have a little snippet of code, and if you look here in the main function, we start off with an int pointer x. This makes sense because this is how we usually would create an integer on the heap. Now, the only difference between creating an integer on the heap versus an array of integers on the heap is what comes after the equal sign. So in this case, we would say new int and then follow it with brackets and the size of the array that you want. And it's that simple. Then, just like usual arrays, we can access the elements by saying the array name, brackets, and the index of the element we want to access. Now, of course, if we have memory on the heap, you know that we are in charge of returning the memory back to the system when we're done using it. Before, when we talked about delete, I mentioned there was one special case where you have to do something slightly different, and that's with arrays. That difference is after delete, you have to put a pair of empty brackets followed by the array name. This lets the system know that you're not just deleting an integer, but an array. And then again, because we don't want to have dangling pointers, we set x equal to null. Now, just to show you that this works, let's compile and run this. Alright, so we see we got no errors. We created this array on the heap and initialized its values fine and everything printed out okay. Now let's run it with Valgrind really quickly just to make sure that we have no memory leaks. And yep, all heap blocks were freed. Perfect. Yes, do you have a question?
How do we access the length of an array?
So in C++, there is no inherent length component stored with arrays. That means you're in charge of keeping track of the length of your array. So if you take a look at the code that we were just looking at my print array helper function here, you'll see that I pass in an integer pointer, which is the start of the array, and then I also pass in an integer representing the length of the array, which I use within my for loop. Good question. Now, one fact that might help you when you're using arrays is understanding what the array name really is. So if I were just to see out the array name itself with no index, I would actually print out the starting address of the array. That's all that the array name is really. It's another way of saying the starting address of the array. So if you take a look at my helper function again, that's why when we call print array, we pass in x as the first parameter, and then in our function signature, that parameter is an integer pointer. This fact might also help us understand what happens if we fall into one of the common pitholes with arrays. Take a look at this code. So again, I'm creating two arrays here, array x and array y, and then here I'm assigning x to equal y. Some people would think that this is equating array x with array y. So x sub 0 equals y sub 0, x sub 1 equals y sub 1, and so on. However, with what we just learned about array names what do you think that this code is going to do? Alright, let's see what this code actually does. So notice that what we're printing out is what the initial value of x0 is, and then what arrays x and y are after we do this equating. So if we compile and we run our code, we see the initial value of the first element of x was 10, but then after we do the equating, it's 0, which is the same value as y's first element. But then each of the following elements of the array have their original value. So basically what star x equals star y accomplished was it set x's first element to equal y's first element. And this makes sense, right? Because we just discussed how x and y are really just the starting address of x and the starting address of y. And those starting addresses are going to be where the first element is stored. If we actually wanted to equate the arrays, or in other words, copy one array into another array, we would have to do something like this. So here I have a helper function copy array that takes in the starting addresses of two arrays and the common length of the arrays. And then it item by item deep copies the value of y into x. So let's compile this and see that it works. And run it. And we see that before copying, they have their different values, and then afterwards, they have the same exact values. If you wanted to resize arrays, you can imagine that the code would look like something similar. Alright, so that concludes our little introduction to arrays on the stack and heap. As always, feel free to ask questions or look things up if anything's still a little bit confusing. Thanks!